questions, I assume that you still remember them, or if you don't, you can just pause the video to reread the question. Now, I never even attempted this problem because I thought it was going to use a lot of cases, but after attempting it, I realized that there is a way to solve this without cases. Okay, let's suppose that x star is the maximum number of cuts we can achieve. Then the usual strategy for finding x star is we find a lower bound for x star. Basically, any set of cuts that we choose, let's say this set of cuts, which is 6 of them, will be a lower bound for x star. X star is the maximum number of cuts, so it must be greater or equal to this number. And then we'll also theoretically find an upper bound for x star, okay, maybe 100. And the idea is that if we can get x star is smaller than some number, let's say 16, and larger than that same number, then x star must be equal to 16. And this is a common idea for finding the maximum value. How can we find a lower bound for x star? What we can do is we can use our intuition to find some good cuts, and basically what we do is the first cut is just random. The second cut, we make sure it cuts the first cut. The third cut, we make sure that it cuts these two lines. The next cut, we make sure it cuts all 3 of the lines. Let's say like that. 1, 2, 3. Then the next cut, we make sure it cuts all 4 lines. Okay, and we can do it like this. First cut there, then cut there, then cut there, and then cut there. And then we can count up the number of regions, and we'll get that there is going to be 16, and so that will be our lower bound on x star. Now, to find the upper bound on x star, we can realize that the more times that each line cuts the previous lines, the more ways this region is cut up. So what we could do is at each point we can count how many ways, we can create a variable for how many ways does the next line cut the previous lines. So we've got line 1, okay. Line 2 can either not cut the previous line, or it can cut the previous line. Let's say that is U1 times the crosses, where U1 is between 1 and 0. And we can easily see that the total number of regions in this image is going to be equal to the original 2 plus U1 plus 1. Okay, what you can do is like a way to reason about that is, let's say U1 is 1. Okay, so there's going to be 1 point where it cuts the previous line. Then that means that this new line is actually divided into 2 sublines, and each of these sublines cut a previous section up into 2, and that means that the total number of regions grows by 2. So that is U1 is 1, implies that 2 parts to the line, which implies 2 extra regions. And if U1 is 0, then this line only has 1 part, which implies that there is only 1 extra region. Okay. So that is for the second line. Then for the third line, it can cross cut between 0 of the previous 2 lines up to 2 of the previous 2 lines. And the number of extra regions it adds is going to be U2 plus 1. So the total number of regions is 2 plus U1 plus 1 plus this. Then for the then for the fourth line, this is between this, and the total number of regions is 2 plus U1 plus 1 plus U2 plus 1 plus U3 plus 1. And for the last line, we get that the number of lines it can cut is between 0 and 4, and the total is 2 plus U1 plus 1 plus 2, U4 plus 1, total number of cuts. And the maximum for this sum is when each one of these UIs have their maximum values. And this is the number of cuts in the image. So the maximum is when U1 is 1, assuming that that is even possible, and U2 is 2, assuming that's even possible, U3 is 3, and U4 is 4. And this is just 1 plus 2 plus up to 5, and that's just 15, this is just 16. So assuming that it's even possible for U1 to be 1, U2 to be 2, U3 to be 3, up to U4 to be 4, then X star would be 16. And we saw that it is indeed possible for that to happen in this case. So we've got that X star is greater than 16, greater or equal to 16, and this over here implies that X star is equal to 16. Okay, sorry that was rushed. It's getting late and I don't want to disturb the other people staying here. Well, assuming that they're not out. I have no idea whether they're actually here or out somewhere. For this question over here, I must construct a pyramid with these sides, and I must find the volume of that pyramid. The volume of the pyramid is just a third height times bar base. The area of the base is, well, it's a square, so the area of the base would just be 36. To find the height, the easiest way is to try and use Pythagoras and to find the triangle that contains height in it. What I can do is I can look at the triangle that lies above this line over here. Okay, so imagine this goes 3D up into a page. When you look at that line will have a length of 6 square root of 2, and above it will be the sides of the triangle that extends above it, and those side lengths will be 6. And then I just draw this. This cuts this in half, and that becomes 3 square root of 2. I can use Pythagoras, and I can find this height is also 3 square root of 2. Alternatively, I could notice that this is a special angled triangle. And now I just have to find the volume, and that is 36 times by 3 square root of 2 divided by 3, which is 36 square root of 2. Okay, we've got some bingo balls which are numbered from 1 to 99, and some of these are missing, and the ones that are missing are even numbered, and there also are all of the factors, even factors, of the sum of all the even balls in the complete bingo set. So we first have to find what's the sum of all of the even balls in the complete bingo set. Okay, so that's the sum of the numbers from 2 to 98. Now, this is just an arithmetic progression, so we can use the rules for arithmetic progressions. This is just the first number plus the last number divided by 2, multiplied by the number of numbers in the sequence, and this just becomes 50 times 49, which, if you were to work it out, you'll get, this is 2450. Technically we don't have to work it out because the next step doesn't require the actual number. Then we have that the balls that are missing are all the factors of this. So let's factorize it. We already know it's 50 times by 49. That is just 2 times by 5 to the power of 2 times by 7 to the power of 2. And it's even factors. So now I can systematically work through all the even factors. So we've got that, let's start with 2 times by 5 to the power of 0 times by 7 to the power of 0. Then we've got 2 times 5 to the power of 1 times 7 to the power of 0. Then 2 times by 5 to the power of 2 times 7 to the power of 0. Let's look at all the ones that have 7 to the power of 1. So this is 2 times 5 to the 0 times by 7 to the 1. 2 times 5 to the 1 times by 7 to the 1. Let's just make sure we don't have a number that's too big. That's just 70. Then if I were to go to 5 to the power of 2, that would be too big. Then let's go for 7 to the power of 2. All the ones with 7 to the power of 2. And let's just make sure we're not going too big. This is just equal to 98. And that is all the factors. Let's just write them out. This is 2, 10, 50, 14. And now I just have to count how many of these are missing. So that means there are 6 missing.